Now let's look at an example of creating an estimate for a different population parameter. So this is from the Gallup poll again, and this was a survey looking at smartphone usage. The report was titled, "Most U.S. Smartphone Owners Check Phone at Least Hourly," and they gave this result 52% plus minus 1%. So what is that plus minus 1%? That is called the margin of error. The margin of error in a study is the value that quantifies the uncertainty of our estimate. So earlier we talked about this idea that when we do an estimate from a sample to estimate the population, there's going to be some level of inconsistency between the true value and our sample value. So we have this margin of error to express how confident we are in how close our results are. So we have this margin of error that's going to quantify how different we expect our statistic to be from the population parameter. A simple formula for calculating the margin of error when you're using a sample proportion, if you are using that p hat in order to estimate some population proportion p, to get this 95% confidence interval, the margin of error is approximately 1 divided by the square root of n. So that 1% in that study was obtained by taking 1 divided by the square root of the sample size. So if we look at another poll from CNN, they interviewed 1,000 people. So what would the margin of error be if we wanted to have 95% confidence? What this is asking is, when we get our p hat from our sample, how close do we think it's going to be from the true population parameter? So the margin of error is going to be approximately 1 divided by the square root of the sample size. So here, 1 divided by the square root of 1,000. And when you calculate this in the calculator, you get 0.0316, which is about 3.16%. Now, if we had only done a sample size of 100, our margin of error would have been 10%. So there's a big difference when we take a larger sample. So clarifying a little bit more on what this margin of error is. When you see a statement like margin of error plus or minus 4 percentage points, that's shorthand for this statement. If we took many samples using the same method we used to get this one sample, 95% of the samples would give a result within plus or minus 4 percentage points about the truth of the population. So I want you to think about that statement again, because what it's telling us is if we were to take lots of different samples, our technique is going to capture the true value of the parameter 95% of the time. So that means that this margin of error is going to be appropriate for 95% of the possible samples. Maybe we got one of the 5% that it did not work for, but we're going to hope that we're one of the 95%. And getting 95% on a test is doing pretty good. So 95% is a high level of confidence. So when you're having to calculate a confidence interval, you take the margin of error and you add it and subtract it from the estimate. So you'll have your estimate p hat, and you'll add and subtract 1 divided by the square root of n, that margin of error. What this is going to do is it's going to provide this confidence interval that gives you an interval of values that you feel confident that it contains the value of the population parameter. Our statistic is being used to estimate what's going on in the population. These confidence statements are giving you two parts, a margin of error and a level of confidence. That margin of error is telling you how close the statistic lies to the parameter, and the level of confidence is telling you what percentage of all possible samples result in a confidence interval that contains the true parameter. So if we take a look at the smartphone usage again, where we had 52% plus or minus 1%, then the confidence interval is 52% plus or minus 1%. If we wanted to get the range of values, we would simply subtract 1% and add 1% and then we get the range 51% to 53%. What this result tells us is that we are 95% confident that the percent of all American smartphone users who check their device several times an hour or more frequently is between 51% and 53%. Another way you could describe that is we are 95% confident that between 51% and 53% of all American smartphone owners check their devices several times an hour or more frequently. That's why the study was able to say the majority of American smartphone owners check their phones hourly or more frequently. Let's look at one more example of these confidence intervals. So in this study in 2011, the Pew Research found that 57% of the 2,146 adult Americans who were polled think that higher education system in the United States fails to provide students good value for the money they and their families spend. So what would our confidence interval be for the true population proportion based on this result? So our p-hat here is the value that's found in the study, 57%. The margin of error is going to be obtained by taking 1 divided by the square root of the sample size, which is 0.022 or 2.2%. So your confidence interval, you take your p-hat and you add and subtract the margin of error. 57 minus 2.2 gives you 54.8%. 57 plus 2.2 gives you 59.2%. So our confidence interval is 54.8 to 59.2%. That tells us that we are 95% confident that between 54.8 and 59.2 of all Americans, or all adult Americans, think the higher education system in the United States fails to provide students good value for the money they and their families spend. Now, the variability of a statistic from a simple random sample does not depend on the size of the population, as long as the population is at least 100 times larger than the sample. So if you were to take a sample of 2,527 from a population of 300,000, then we take a sample of 2,527 from a population of 1 million. Which sample statistic would have more variability? Well, in this case, neither one would have more variability because the sample sizes, they are the same, and the population size isn't going to affect the variability as long as you can take the sample size, multiply it by 100, and you're still less than the population size, which we are in both of these cases.